Okay, so here's example 4. And so now if we look at the previous example, if you go back to the previous example where I mentioned that there are going to be like 27 determinants that we're going to add up, okay? Now, and I also said most of those are going to be zero. But here's another thing to keep in mind. In each, now if you look at just these 3 right here, these are just 3 examples of those 27, okay? In each of these examples here, you see that 2 of the entries are from the original matrix. For example, the 2 and the 4 are in the same column, and they're from the original matrix. If you look at the 5 and the -1 here, they are from the original matrix. And also here, the 5 and the 0. I put a little asterisk here because this 0 here is from the original matrix because there's a bunch of zeros. So we had to distinguish between the 2. So these 2 here are from the original matrix. Now, the thing is why that's important is because if you have these 2 from the same matrix, then guess what? This is a multiple of this one, which means that this matrix is singular, okay? Which means the determinant is 0. So we can just eliminate any of these determinants where the matrix has 2 original entries in the same column. And so what happens when you reduce that and you get rid of them, guess what? You end up with just 6 determinants that you're going to add up. And so these are the 6 determinants. So if you see, now let me erase this because we're going to need more room here because I want to show something here. So now, looking at these 6 determinants that we want to calculate out, notice that now what we can do is we can factor out these 6. We can factor out what am I trying to say? We can factor out the numbers from each of the rows, right? Using the properties that we talked about. So we can factor out the 2 from this row, the 3 from this row, and the 5 from this row. And then we can factor out the 2 from this row, the 0 from this row, and the 1 from this row. We can factor out a 1 from this row, 4 from this row, 5 from this row. We can factor out a 1, a 0, and a 2. We can factor out a -1, 4, and 1. And we can factor out a -1, 3, and 2, right? So what is that going to give us? Well, watch. So I'm going to continue the equality up here. So that'll give us what? 2 times 3 times 5 times what? We got 1, 0, 0, 0, 1, 0, 0, 0, 1. Plus, then we got 2, 0, 1. So I'm going to add the 0 just for completeness so we see what's going on. So we got 2, 0, 1. And so that gives us the matrix 1, 0, 0. 0. What is that one? So that's the 0, right? Hold on, I think I'm missing something here. Oh yeah, here we go. I'm going to put asterisks there. So this is the original 0, so I'm going to put an asterisk there. Let's put asterisks so we know which is which. And this one. Okay. Okay, now we know, oh, hold on. Is it the first matrix? Yeah, okay, good. Just want to make sure that I'm doing this right. So, wait a minute, why is it, or did I put the 0 in the wrong place? Oh yeah, okay, never mind. Okay, I'm confused myself. Okay, so I factor out the 0 here, so the 0 is going to be here. So there's a 1 there, okay? And then, yeah, so the 1 goes there. So 1, 1, so yeah, okay, I was right. Okay, so 0, 1, 0. Okay, good. Okay, so now we go on to the next one. So plus, now I'm going to factor out, now we're on this one. So it's going to be 1, 4, and 5. So it's going to be 1, 4, and 5 times, now this one is going to be 0, 1, 0. 0, 1, 0, 0, and 0, 0, 1 for that one. Plus, and now we're on this one, which is going to be 1, 0, 2. 1, 0, 2. And that determinant, the ending determinant is going to be 0, 1, 0, 0, 0, 1, 1, 0, 0. And plus, and finally, the last two are going to be negative 1, 4, 1 times 0, 0, 1, 1, 0, 0, 0, 1, 0 plus negative 1 times 3 times 2 times the determinant of 0, 0, 1, 0, 1, 0, 1, 0, 0. All right, so now, okay, so now, what do we have here? Now, look at this. Now, recognize that these matrices in here, okay, are what? These are permutation matrices. Permutation matrices. So that's something to observe, right? Now, notice that now all we have to do with these determinants is swap rows and keep track of the sign change and get them into the identity. So we just swap them. So now watch what happens. So here's the thing. So this is already the identity. I don't have to do anything there. Here, in order to get this to be the identity, I just have to switch these two rows, which means that this is going to end up being negative. So if I do that, this will become 1, 0, 0, 1. So I put a negative sign up there because it's going to change the sign to negative. Now here, what do I have to do here? I have to swap these two. If I swap these two rows, I've got the identity. And so I put a negative sign there because it changed the sign. And now here, this I have to swap twice because I'm going to have to swap these two, right? And then I'm going to have to swap again. So let's swap these two. So I'm going to do 1, 1, 0, 0. Okay? So now that I did that, now I have to swap again rows 2 and 3. So now this will become 1, 1, 0, 0. So now I swapped twice, which means it's a negative times a negative, which stays positive. And so now again here, you see again, I'm going to have to do, I'm going to have to swap twice again here. So I'm going to have to swap these two and then swap again. So if I swap these two, this is going to become 1. This is going to become 1. This is 0. this is 0. And then I'm going to swap these two, and then this will become 1, and this will become 1, this will be 0, this will be 0. And so I did it twice, so it's going to negate each other, right, the two negatives, so it stays positive. And now here, I just have to swap the first and third row. So this one is going to be 1, 0. This one is going to be 0, 1. So that's going to make that negative. Okay, now, the best part is all of these determinants are just going to be 1. Okay, so the final result is just going to be what? This is going to be 30 times 1 minus, because of the minus sign, minus what? 2 times 1, because this is 2 and this is 1, plus, oh, now this is a minus sign, so this is going to be minus, this is going to be 20 times 1, and then of course plus 0. Oh, hold on a second. Oh, I'm sorry, this is 0. No, not 2, 0. So that's 0, and that's 20, and then that's 0. So it's going to be 0 times 1, right here. This is going to be negative 4 times 1. And then minus a negative 6, so that's going to be plus 6 times 1. And now, all we have to do is simplify. So this is going to be 30 minus 0 minus 20 plus 0 minus 4 plus 6, which ends up being 12. And that's it. Now, in this example, it captures this, this subsection's new calculation scheme. So multilinearity expands a determinant into many separate determinants, each with one entry from the original matrix per row. Most of these have one row that is a multiple of another row, so we omit them, like we did here. We are left with the determinants that have one entry per row and column from the original matrix. And then factoring out the scalars further reduces the determinants that we must compute to the one entry per row and column matrices where all the entries are 1. And by the way, we notice that their permutation matrix, their permutation matrices that we talked about in earlier videos, earlier chapters. And so now we're going to introduce the notation for permutation matrices.